Okay, last problem, and it's up in appearance at least, it appears to be a perfect cube problem where the first term of the binomial would be 6m squared. Now, why is that? I'm looking at this, and 6 cubed is 216. 36 times 6, 180 and 36, which is going to be 216. Works out beautifully. Now, it's an addition problem. Put this over here. Let me cross this off. And I'm looking at the 343, and I'm going to say that's 7 cubed. All right, so 7, and then it's going to be what? X cubed. Well, 7 times 7 is 49, times 7. Well, if I did 7 times 50, that's 350 minus 7, so 343. So it seems to be working out okay. Now, what I always say is that, I'm just looking at the first and last. My big concern is I wonder, does it give me the middle? So I'm the kind of person that would actually check it, all right? You might say, no, I'm just convinced that they're not going to ever trick me. But sometimes you are tricked. So let's vote it down. What are you going to get? I'm looking at the middle terms, though. These are the tough ones for me. So it's going to be 3, 6m squared, 7x cubed. Well, you know what? I'm going to do the letter search because it's easy. And what do you get? m4x cubed. I'm seeing that. Now, the big problem now is for me, do I see the other number? Well, what I would do is I would do actually 3 times 7 first, which is 21, and 6 squared is 36. I would do the arithmetic. That's going to be 36, and 2 times 36 is 72. And what is that going to give me? 7, 5, 6. Bingo, all right? Now, someone says, do you really want to check the next one? Yeah. What's the next one going to be? 3, 6m squared, and then 7x cubed squared. What do you get over there? Well, the letters are pretty easy. What do you get? M squared x 6. I'm definitely seeing that. And now I got to do these numbers over here. Well, 3 times 6 is 18, and 7 squared is 49. Yep, I'm going to do it. 10 times 49 is 490. 8 times 40 is 320. And 8 times 9 is 72. 2, let's see, 7, 9, 18. 5, 6, 7, 8. 882. Am I getting that? Yes, I'm getting that. So I'm convinced that this is a correct answer, right? Do they list that as a correct answer? Of course they do. Make sure you look at the key, right? But don't be so convinced that things work until you verify that they work. A lot of times what happens is they're called distractors. They put a problem down. It looks like it works, but it's actually more complicated than it appears. So if you're just looking at the first and the last and assuming it's working, I would stop doing that because that's not necessarily true. Okay, thank you.